All right, so we're making some pizza here. And Selena, she takes pizza out of the oven and then it starts to cool. So this is the classic cooling, whether it's pizza or coffee or hot chocolate, whatever, but it starts at a temperature. If down here, my room temperature is here, when you think about it, it can never get colder than that. So if it's just sitting out, so that becomes an asymptote. So it's an exponential decay problem. You know, your multiplier is between 0 and 1. That makes it get smaller and smaller and smaller. And again, it'll just continuously approach. At first, it changes a lot more rapidly up here because there's a lot more difference in the room temperature and the temperature of the pizza. But as it gets closer and closer to the room temperature, it's going to change less and less as time goes on. So that's kind of the situation we have. And so Selena took some different temperatures of the pizza. You can see the first one was after it was out 5 minutes down to 25 minutes. And the problem says she wants to serve it once the pizza gets to 150 degrees. And that's the question. How many minutes is it going to take before we get to 150 degrees down here? So the problem suggests using regression to solve this. And so over here, we're going to jump into Desmos. I've tried to save a little time by already typing in the data for you. I'll show you what you need to do if you don't know how to do that though. Oh, not that bro. Let me get to a Desmos screen here. If my tab gets out of my way up there. Let's see here. Can't get to my, I've got a tab open up there. Let me pause this for just a second. Okay, so now let me share this Desmos screen with you here. I've already typed the data in. If you don't know how to get that table there, it's the plus sign and just table. And then you just type the numbers in. Now right down below here, we need to run a regression. So the calculator is called residuals. It's going to find the line that goes through these the best. You can kind of see that exponential decay in the points there. Oh, and I already adjusted my window settings here for this little wrench for the settings. If I came down here, you know, my X numbers went from 5 to 25. So when I'm in here, I want to make sure that fits in between that range. I always like to have a little bit of a negative there so I can kind of see just perspective of where the negative X's are. And then on my Y's, they go up to like 300 and whatever. So as you see right down here, just make sure it goes higher than that. Again, I like a little bit of negative so it shows on my screen, just so I can tell where I'm at compared to that X and Y axis. But those aren't an exact thing. That's just making sure that the points are fitting in those ranges. All right, so we've got the grid set the way we want. We've got the data entered in there. We can see those points. And then to run the regression, it's right down here. You at the top of this column, see your Y1 and your X1. That has to be in your formula here. So it's your Y1. I think we've done this before, but just in case, shift, and to the left of the 1, there's the tilde, T-I-L-D-E, with the little hyphen-like thing up there, tilde, and then it's A times B to the power of, and then don't forget your X actually has a subscript 1 on it also. This log mode, this is the normal way to do this. So I would just recommend always having that check mark in there. It does it based on transformations, which is the normal. So you can get both the R squared and the R. And then, so again, this is like that 92, 96% match of the data to the line, you know, a little bit above, a little below sort of thing there. So, and then here's your equation. So I'd have my 334.911, and I'm just jotting this down so when I go back over there to our work, I've got it, the 334.911, as long as I entered my data correctly. And then the B, the multiplier is 0.97102. That's how much it's cooling by to the power of X, okay? So that's how you run the regression, and then these points down here plug those into your A and B, change it back to just a regular X and Y, and then we've used that data to come up with the equation. Again, these residuals, how much is above and below, and it tries to minimize that. The computer does that for you, actually. All right, so after you got that much, then let's go back to our problem. So our equation again came out to this 334.911 times your 0.97102 to the power of x. And they said they want to know when this equals 150. So if you've got that much so far, and we're trying to solve for the x up there, well, what do we got to do for that? We've done these before. You divide by this coefficient. And then you're going to find out what this is, whatever that is, equals a base to a power. Your power is the exponent. Then you go to your log. Log base 0.97102 of what it equals over here, this answer, becomes the argument of your log. And it equals the exponent. If somebody wanted to do it as a graph, you could also graph this in Desmos as y equals, and you could put a second equation in that says y equals 150 and find where they intersect. And then remember up here, it does say round up to the nearest whole number, but round up, not round to the nearest, but I'll automatically go up. So let's, again, I'm gonna now jump over to Desmos and actually evaluate that log base 97102 of the 150 over 334.911. And that'll just be calculating in Desmos, or use, if you know your calculator, use that. So I've got log, and then remember for the base, it's shift and the underscore. That'll put it down in the subscript, the 0.97102. Well, that wasn't right. I might have somehow, I got all the way down below. Let's get down into that subscript. 0.97102. Arrow to the right to get out of that subscript and put my fraction in of 150 over 334.911. Enter, and we've got our 27.3, but it said to round up, so I'm going to say 28 minutes before the pizza's ready. Again, if you had wanted to put the y equals on your graph and do this problem just using equations, you certainly could do that. You would put in your y equals the starting number, that was the 334.911 times my multiplier of point, since it's cooling, less between 0 and 1, 102, to the power of x. It's going to give us a graph. That was that one we already had there. And then if I wanted to find out when it actually hits or equals the 150, put the 150 in there, and right there I've got my same 27.313, same answer I had right up here. So rounding up 28. But that would be my method for doing that problem, not to say there aren't others. But good luck with that one.